It's 521 million years ago during the Cambrian period of Earth's history, and you are diving to the shallow ocean floor to watch trilobites. This far back in time, in these exciting primordial days of multicellular life, the reef is crawling with interesting and strange creatures. And right in the middle of the action, there are trilobites, nothing less than icons of the Paleozoic era. This class of invertebrates are not just synonymous with ancient life, they're also extremely successful and long-lasting, and took on some pretty wonderful shapes and sizes. Trilobites lived for almost 270 million years, from the brave new world of the Cambrian explosion to the dark times of the end Permian extinction. So, to understand and follow their incredible journey, let's take a look at what trilobites are, how they behaved, how their bodies are laid out, and what happened to them. You are diving underwater in a shallow coastal zone, gliding over a soft, silty sea floor. Overhead, gentle rain creates mystical circles on the wavy, watery ceiling above. This place will one day be a fossil deposit in the Emu Bay Shale on Kangaroo Island, one of Australia's most Australian-sounding places. Here in the Cambrian Stage 4, you're somewhere near the Tropic of Capricorn. The climate is sweltering, and the oceans are balmy. For animal life on Earth, it's go time. The evolutionary arms race is in gear. The Cambrian explosion is underway, and most of the phyla in the animal kingdom are emerging. By this specific point in the Cambrian, we have massive diversity of animals called the small shelly fauna, like halcyon-annelid mollusks, Aldanotreta brachiopods, crinoids like Gogia, early sponges, mysterious shelled ice cream cones called hyoliths, possible annelids like Myoscolex, and worm-looking things called tomateids. And scuttling through these slow and immobile creatures are big sea bugs with unmistakable crescent moon heads, segmented thorax, and plenty of legs underneath. These ones are called Redlickia rex. Some are scuttling around a cluster of sponge towers and broken Maricella shells. They're probing around with their long antennae, looking for food, changing direction, interacting, and fidgeting. Before we dive in, what exactly is a trilobite? As mentioned before, a trilobite is an arthropod, an armoured invertebrate with a calcite exoskeleton, a kind of calcium carbonate polymorph, the same hard material as an oyster. They are divided into three lengthwise lobes, a central axial lobe and left and right pleural lobes, which gives them their name. They had a head called a cephalon, a thorax made of many segments, and a tail called a pygidium. Like all arthropods, they replaced their shells by molting in order to grow larger. Because of their abundance, durable shells, and molted exoskeletons, they typically fossilized extremely well. They had very sophisticated eyes, long antennae, and variable numbers of non-armored legs. They had different kinds of diets ranging from predators, scavengers, filter feeders, and detritivores. Some were active in shallow reefs, while others lost their eyes and adapted to the darkness of extreme ocean depths. Burrowing trilobites buried themselves under the sand, and some were even able to swim. Some trilobites walked together in single file, possibly to save energy, stay together, or avoid predators during migrations. Others folded in half, or rolled into balls for protection. Over 22,000 species have been described so far, and while some may have briefly popped onto the beach for excursions, every known species was exclusively marine. And what colour were trilobites? Well, besides indications of spots or markings, we don't really know. While their fossils are typically brown, black, or red, those colours come from the mineralization process. But if you look at other arthropods, from insects to spiders to isopods to crabs, they come in a wide range of amazing colours. So, I'm following suit in my paleo art. While deep-sea abyss trilobites likely didn't have flashy colours, let's imagine reef-living trilobites as colourful and spectacular. Reefs are colourful places, so let's let trilobites be colourful too. The trilobites were one of the first major arthropod classes to be established. Chelicerata, which includes modern arachnids and superficially similar horseshoe crabs, would also appear in the Cambrian, and so would crustacea that would eventually include modern lobsters and true crabs. Other arthropods appeared later, Myriapoda, like centipedes and millipedes, would pop up in the Silurian, and hexapoda, which includes insects, arose in the Devonian. Trilobita, in a sad way, is the only one of these classes which is now fully extinct. The proving ground of the trilobites was the marine realm of the Cambrian. By the time the very earliest trilobites, like Redlickia, appear in the fossil record about 521 million years ago, they were already very sophisticated, complex, diverse, and widespread in oceans around the world. This indicates that trilobites had already been on the scene for quite a while. So what did they evolve from? What came before trilobites? That's still kind of a grey zone, because evolution during the Cambrian explosion happened so fast. The earliest ancestors of trilobites might go back to the Ediacaran period. Some speculated ancestors include Sprigina, Precambridium, and Parvancorina, which are superficially trilobite-shaped blobs that slid around on the microbial mat. However, Arthropoda and the greater clade Panarthropoda probably evolved from a segmented worm ancestor. Early arthropods in the Cambrian under the clade Arthropoda, which includes trilobites, includes the animals of Vasicochordata. These tiny, soft-bodied animals like Sydneyia had limbs and appendages which could use to crush and eat hard animals, including juvenile trilobites. Emeraldella was another larger example with a long tail spine called a telson. The closest relatives just outside crown group trilobites are the trilobitomorphs, like the order Nectospida, Conciliturga, and Xandarolida. Some of these trilobitomorphs, like Nectospida, coexisted alongside true trilobites well into the Silurian period. Wherever trilobites came from, by the mid-Cambrian, they were already masters of the ocean floor. Now, there's not really a typical trilobite, so to visualize their massive diversity over such an insanely long time frame, let's meet the 10 currently recognized trilobite orders, the major subdivisions of the class Trilobita, plus one bonus group. The group that's typically considered the first of the trilobites, possibly the ancestral group to all others, is Redlickia. They popped up around 521 million years ago, during the early years of the Cambrian explosion, marking the start of the reign of the trilobites. They are primitive, flat, and oval-shaped, with a large semicircular cephalon and a very small pygidium. They have large half-moon-shaped eyes, long genal spines sticking out from their heads, and have no facial sutures. Redlickia, like Phalotaspis and Balcarocania, spread around the world, becoming globally distributed. Tychoparida is an order of primitive trilobites with a long thorax, often with more than 12 segments and a tiny pygidium. The Tychoparida order is very large, heterogeneous, and diverse, which makes it difficult to describe them with generalized terms. They include Elrathia kingi, usually considered the most commonly collected trilobite of all time, Norwoodia bellaspina, named the Beautiful Spine, and Conchoreef, deep-sea bottom feeders that had no eyes. The next group that arose in these early years was Corynexichida. These trilobites like Coutinia had opisthoperian sutures, a kind of facial line that splits and releases their cheek fragments when they molt their exoskeletons. These different types of facial lines might seem trivial, but they're a key part in classifying trilobites. They had a box or pestle-shaped glabella, the central bump thing on their head that contains part of their digestive system. They had large bow-shaped eyes, an oversized pygidium, and they were often spinos, which means covered in spikes, such as Olenoides, which had spiked thoracic segments. Next, let's meet Agnostida, trilobites so strange that it's sometimes debated if they even are trilobites. They are very small, with a pygidium the same size and shape as their cephalon, only 2 or 3 thorax segments, and often have no eyes. Genera such as Pagetia were likely deep-sea detritivores. Their party trick? It's speculated that they could fold in half for protection, like a wallet. Our fifth order, Odontoplurida, is the last to arrive in this early part of the Cambrian. This was an order of supraspinos trilobites. Genera such as Damselella had a bar-shaped head with a round glabella, a long thorax with 8 to 13 segments, and a very small pygidium. With so much diversity already in play, The Cambrian period shaped up to be the heyday of the trilobites, their gilded age. But as life on Earth was evolving quickly, the creatures that couldn't adapt to a changing world went extinct. Around the Middle Cambrian, 500 million years ago, our first order, Red Lochida, became the first to go extinct. While the little crescent moon eyes of Red Lochida would be gone forever, new orders continued to appear later in the Cambrian as they branched off from the established groups. Welcome to the family Asaphida, one of the largest and most diverse trilobite groups, making up around 20% of all trilobite fossils. They were trilobites with distinctive round rims around their cephalon, rounded pleural lobes, and a large round or triangular pygidium similar to the head size. Another proposed order, but not formally ratified, is Trinoclida, which branched off from Asaphida in the Ordovician period. These sea bugs like Cryptolithus and Ornea also had a distinctive brim along their head shield, perforated with round pits, often with extremely long genal spines. Their cephalon was huge, sometimes bigger than their thorax, and they had a narrow triangular pygidium and were often eyeless. Eyeless trilobites are called atholoptic, and they usually indicate that they lived in dark, extreme deep-water environments, or they may have been burrowers. Most trilobites did have eyes, and even by today's standards, they were very advanced. They were rigid compound eyes, similar to the ones insects have today, but made of calcite mineral lenses. The oldest, and by far the most common trilobite eye, is the holochroal eye, which has a single cornea covering an array of individual lenses called ommatidia. Sometimes an individual eye could have more than 15,000 lenses, which process light to form a mosaic of images. Phacopoda is our next group of trilobites, with a distinctive extended glabella, proparian sutures, and the ability to roll into balls. They developed an even more advanced eye in the Phacopina suborder. This schizochroal eye had isolated lenses, separated by tissue called sclera. Each one was covered by their own cornea that covered the lens and sclera, offering superior vision resolution, depth perception, and night vision. The rarest trilobite eye was found in the order Pagetia, part of Agnostida. The bathychroal eye had up to 70 individual lenses with their own corneas limited just to the lens. Alongside Phacopoda, the order Lochida also appeared in the final epoch of the Cambrian, the Ferongian. Lochida are another spinose group, closely related to Odontoplurida, with spines so long they are sometimes longer than the entire body. They have a large pygidium and a long glabella. Lochida includes some of the largest trilobites ever found, like the intimidating Terataspis, and are notable for their grainy texture that looks like warts or small spines. The order Harpatida is our ninth group that arose in the Cambrian. Harpatida, like Entomaspis, are usually recognized for their large heads with sensational semicircular brims that look like horseshoes. Their heads were sometimes dotted with small paws, thought to be a filter feeding tool or a sensory system. They usually have small eyes and a small pygidium. By the early Ordovician, the trilobite golden age that started in the Cambrian continued on in the warm oceans. By this period, Odontoplurida were becoming very spiny, with genera such as Odontopleura, Selenopeltis, and the extravagant Radiaspis becoming masters of defense. In Corynexichida, the large trilobite Bumastis roamed the Ordovician reefs, with its distinctive smooth, rounded shape. Hibatia was starting to perfect the wonderful Harpatida head shape, while the Asaphida giant Isotellus rex grew to become the largest trilobite ever recorded. While all the established orders were flourishing, our 10th and final order of trilobites, Proetida, arrived on the scene. They were typically small, with long genal spines, large eyes, and 8 to 22 segments. Remember Proetida, they'll be important later. Like most life on Earth, trilobites were not prepared for the devastating effects of the late Ordovician mass extinction. The climate events at the end of the Ordovician plunged Earth into a major ice age, and then flipped back within a few million years to a greenhouse climate. As profound sea level drops devastated shallow water ecosystems, the deeper oceans were choked of oxygen, and trilobite diversity was shattered. 70% of trilobite genera went extinct, and 50% of families, most notably affecting the deep water trilobites. This is where we say goodbye to two entire trilobite orders, the weird head or tail Agnostida and the primitive Tychoparida. Asaphida was reduced to one single trinucleated genus. In the Silurian period, trilobite diversity was halved, and their glory days were in the rearview mirror. But while most remaining orders developed adaptations to survive, Asaphida was in dire trouble. Sometime in the mid-Silurian, the last trilobite of the Raphiophorus genus rolled over, curled its legs, and died, extinguishing one of the great orders of Trilobita. While the Ordovician was tragic for the trilobites, the Devonian would be devastating. But they wouldn't go out without first showing off their most fancy, bug-eyed, spinose forms. With the rise of jawed fish, especially some extremely large shell-cracking terrors, sharp trilobite spines were more critical than ever for their survival. Corynex was evolving some of its spiniest trilobites ever, like the absolutely wild Heliopeltis. Odontopleureida trilobites like Dicronurus were growing some of the most sinister spikes ever seen on trilobites. Harpetida trilobites became beautiful semicircles, like Bohema harpies and Scotoharpies. And this is Pterotaspis, estimated to be longer than 60 centimeters long, and one of the largest trilobites ever to live, known for its wild spikes and extreme bumpy texture. Even the hungriest placoderm wouldn't eat what is essentially a skateboard, lined by bread knives. Acanthopyge and Ceratagis were some more crazy, spiny Lachaeda trilobites. Then, 386 million years ago, an oceanic anoxic event called the Titanic Event killed off Lachaeda, our friends with oversized spines. These bugs lived in shallow reefs and had planktonic larvae, tiny ocean-drifting babies, which were especially susceptible to the anoxic event. As the Devonian drew to a close, two even more destructive events ravaged the remaining trilobite orders. About 372 million years ago, a massive anoxic event caused the collapse of reef ecosystems across the planet. This Kellwasser event caused the extinction of the diverse Corynex, the horseshoe-shaped Harpetida, and our last spinous group, Odontopleureida. Only two orders were left after the Kellwasser event, Phacopida and Proetida. But after such a battering, Phacopida was hanging on by a thread. 13 million years later, at the very end of the Devonian, the climate change and mass extinction of the Hangenberg event finished off Phacopida. Choked off from oxygen, the bright spark of the last schizocoral eye went out forever. As the Earth's oceans recovered after the Devonian period, Proetida was the last order standing. The little guys, on their own against a Paleozoic ocean filled with sharks, ammonoids, and tetrapods. Like many survivors of mass extinctions, Proetida were generalists, flexible in times of crisis. They were omnivores and lived on reefs as well as in deeper water. They also had larvae that developed differently than other orders, perhaps offering a survival advantage during their planktonic early stages. Despite the setbacks, Proetida branched out into a fairly wide diversity. There was Linguaphilipsia in the early Carboniferous, Ditomopyge, and Griffithides. For 120 million years, nearly half of the trilobite's complete temporal range, Proetida carried the torch alone. Over the Carboniferous and the Permian, they were gradually whittled down until one last genus, Pseudophilipsia, remained. When the apocalyptic Permian-Triassic mass extinction swept across the planet 251.9 million years ago, erasing 81% of all marine life, the last genus of trilobite, Pseudophilipsia, had no chance. As entire marine ecosystems collapsed around them, these final trilobites failed to develop their shells in the acidified oceans. And that was it. The last of the trilobites were extinguished, and the order faded away into deep time. They were prominent parts of Earth's oceans for 250 million years. As the Mesozoic began, they were forgotten for another 250 million, until Homo sapiens began to question what these curious bug shapes were in the rocks. What a journey. You snap out of a daydream and remember you're still in the bright, optimistic days of the Cambrian. Look, one of the red Lachia is still crawling towards you. You place your hand against the silt, and a puff of fine crystals rises silently into the water. This creature feels a lot more familiar now. There are its 3 lobes, It's cephalon with genal spines and without facial sutures. Its sickle-shaped holochroal eyes and raised glabellum, segmented thorax and small pygidium. It approaches your hand, brushing its antennae against your glove and wetsuit. It climbs aboard and you lift your hand up. It's as big as a sandwich, and with strong pointed feet, it crawls from the top of your hand to the underside of your arm, much faster than you expected. It sends a shiver down your spine as you feel tiny legs trying to crawl into your armpit. That's a big bug. It's kind of creeping you out. But what a privilege to interact with one for real. What a shame we'll never see these creatures in the modern day. Some speculate that some ancient, undisturbed population might still exist in some forgotten deep-sea enclave. But that's likely just wishful thinking. But for now, thanks to the wonderful fossils they left behind, their memory is alive and well in our museums, our textbooks, and in our imaginations. Trilobites, we still remember you after 500 million years. Thanks to all my patrons who are supporting me on Patreon, and a special shout out to the Longisquama tier, the superfans listed on the screen. And, as always, if you're interested in learning about the worlds of deep time, make sure to like and subscribe.